What an incredible introduction to the whole conference, DPW 2025. And hello, Amsterdam. It's so great to be here with you. It's so great to be here at DPW 25. We're here to talk about AI. And if you're like me, we're getting bombarded by the noise, the hype, and the promise daily associated with AI. In fact, I think a day barely goes by when there isn't a new headline or new major claim in the news. So if you're feeling a bit overwhelmed by it, don't worry. I think we all are. OK, so for today, the organizers asked me to try and cram in about 30 years of technical information into 19 minutes. So for the next 150 slides, no, I'm just joking. But I did try to think about what would be the most impactful insights that I could leave with this audience today? And I came up with, hopefully, 3 that I'll make the argument for. First, I will argue that we're on the precipice of a technological shift potentially more significant than the Industrial Revolution. Second, I am going to make the optimistic case that AI will provide incredible value. But I'm also going to temper it by saying that that value will not be inevitable. It's going to take hard work from you. And then third, I want to leave you with actionable insights that you can take today that will move us from being users of AI to directors of the technology. So let's jump right in. DeepMind's mission is to build AI responsibly to benefit humanity. I mean, what an incredible sentence to be able to put on a slide, right? It's one sentence that means so much. I want to start with the build AI part, and then I'll come back to the second part shortly. When I started in the space in AI, it was a fringe science. And if you wanted to talk about artificial general intelligence, it was even harder to have a serious conversation about it. But today, it seems like it's the defining technology of our era. And you might be asking, why should I care about this era-defining technology? Well, for me, it's the promise of using AI, and maybe soon AGI, to scale one of our most precious resources, human ingenuity. This ingenuity, this problem-solving capability, it's the reason why we're here. It's the reason why, against the universe's unforgiving march towards increased disorder and entropy, we've been able to build civilizations that can prosper. But how did we do it? We didn't necessarily get an instruction manual for the cosmos. We made progress by observing the complex, chaotic, and often beautiful environments around us. And we problem-solved within those environments and exploited those for human progress. Think of the agricultural revolution over 12,000 years ago. It enabled stability in food and land and labor, and that helped to lay the foundations for modern civilization. But here's the fundamental challenge, I think, for our era. The complexity of the problems that we face today, from climate to health to virtually every industry sector, they are scaling faster than our unaided ability to solve them. Powerful AI systems will help us to break through that bottleneck, and that's what really excites me about the promise of this technology. AI has the potential to be the biggest force multiplier for our problem solving. So, testing and scaling AI systems in the real world can often be hard, difficult, maybe impossible, or even dangerous. So historically at DeepMind, we've turned to games. Games are microcosms of universes with very clear rules. One such example of the board game was the board game Go, where, if you're not familiar, Go is arguably one of the most challenging strategic board games ever created by humans. In fact, there are more possible moves in the game of Go than there are atoms in the known universe. So what that means is you cannot calculate every single position of the game of Go. It also means humans, even with over 2,000 years of playing this game, we've only been able to explore a very small part of the game's universe. In 2016, our AI system, AlphaGo, faced off against world champion Lee Sedol in a series of matches. It was the second game. In the second game, AlphaGo managed to play a move that was so surprising, it stunned the whole Go world. And it was memorialized as Move 37. It was so surprising that the match actually had to get suspended for a few minutes, which took us by surprise as well. It was a move that actually defied over 2,000 years of human knowledge on how to play the game. But the crazy thing was that the move wasn't an error. it turned out to be a very beautiful and decisive move from a part of the Go universe that we just hadn't visited yet, even after 2,000 years. And so we realized then that we hadn't necessarily built a machine that could just copy human experts. We'd built a sort of Hubble telescope to help us explore different unseen parts of the Go universe that we just hadn't been able to explore yet. But of course, we hypothesized that this ability to explore complex, vast spaces extended well beyond games. And so we looked to apply it to scientific discovery. And so we turned our attention to a grand challenge that had stumped biologists for 50 years, the protein folding problem. Why protein folding? Well, proteins are the building blocks of life. And in his 1972 Nobel Prize lecture, the chemist Christian Anfinsen laid out the challenge for us. He said, can we predict the three-dimensional structure of a protein from the single one-dimensional series of amino acids? Solving it would be revolutionary because a protein's three-dimensional shape, the way that it folds, determines its function, how it works, what happens when it breaks. And of course, there's only one way that a protein can fold from that single one-dimensional amino acid sequence. In 2021, our system AlphaFold solved it and was able to predict the folded structures for all 200 million proteins known to science. Now, to put that in perspective, usually to determine the structure for one protein, it takes a PhD and maybe 5 years. And so we're talking a collective of saving maybe a collective billion years of work in order to be able to fold all of those proteins. But we didn't stop there. We also released the entire database to the world for free as a gift to humanity. And I looked this up recently. We now have over 2 million researchers across 190 countries using AlphaFold to accelerate scientific discovery. Everything from studying neglected diseases to drug discovery. And just last year, this AlphaFold breakthrough was recognized with the Nobel Prize in Chemistry. Absolutely astounding. But it was an important proof of concept for us that the ability to find deep patterns in complex spaces like Go could help to unlock some of the secrets of biology. And this brings us to the second part of the mission that we looked at earlier, to benefit humanity. AlphaFold, in some ways, was just the blueprint. We're now applying that blueprint across the entire landscape of human endeavor. It means pointing these really powerful systems at our planet, building AI to forecast extreme weather and floods to save lives. It means looking out to the cosmos, to space, to decode the faint gravitational whispers of colliding black holes to understand the fabric of our universe. It also means looking inward at ourselves to decode the language of our DNA to design the next generation of life-saving therapeutics. From deciphering ancient damaged texts lost to history to discovering new maths, this is what we mean by being a force multiplier for human ingenuity. And it's an incredible opportunity to bring these to bear on our hardest challenges. So, how do these breakthroughs actually come to be? Well, maybe it's not a surprise, but it turns out through decades of patient and deep commitment to fundamental science. You'll see this come up in my recommendations to you very shortly as well. And here we just look back at the last 10 years or so at Google's part in our innovation history. One thing that I'll call out is the 2017 invention of the transformer architecture. In fact, this one invention, this transformer architecture, underpins nearly every single generative AI model in the world that you see today. And so, as you can see, we've been building on and contributing to a rich tapestry of innovation across the world. On that amazing foundation of innovations, we can then look at the frontier of technologies that are available in the world, and we'll look at it from the perspective of Google today. At the heart of it all is Gemini, the natively multimodal foundation model. Gemini has been built from the ground up to enable scaled intelligence for all use cases. In addition to Gemini, I'll also call out the generative media models, so we'll start with Nano Banana. Nano Banana, by the way, is a great lesson in accidental marketing. It is our frontier image generation and editing model. And I also call out Veo, which is a model that is able to produce video and audio from a single prompt. And if you were curious about my first title slide, by the way, it was made through a combination of Nano Banana and Veo. What blows my mind about Veo, by the way, is this is a model that has somehow learned some of the physics of our world. So when you generate a video, it knows how the light needs to reflect off of certain objects, or it knows what needs to happen to the water when you step into a puddle. It's absolutely incredible. And of course, all of these models have to cut across every single modality. And that's because the real world is extraordinarily complex. And these models have to understand that complexity. So we're systematically pushing the performance on every axis to deliver the most capable and helpful experiences in the world. When it comes to AI, though, I also want to emphasize that it's not just about that model layer, those innovations. To power the entire frontier of research, it requires a completely different way to think about the end-to-end system that you can see here. And importantly, the stack that you see on this slide, it doesn't just apply to Google. It applies to every single business. You'll have to have some form of this. So starting from the bottom here, Google's been able to design and build its own machine learning computers. On top of that, it's been coupled with AI-first software tooling that accelerates innovation velocity. And then on top of those core technologies that we talked about is where agentic platforms are built to enable applications and services. The outcome is an innovation engine specifically designed to accelerate impact and benefit humanity. And that's the same engine that powers our ability to apply AI across all of Google's products and services. But it's also the same engine that we use to partner with businesses for incredible impact around the world. But the crucial question, I hope, that's on everyone's mind here is, OK, but how do we take it from the lab into our businesses? I think one important piece that I'll talk about today lies in the evolution of this technology with AI agents. So again, I want to cut through the hype here. At its core, an agent is essentially a system that can plan, reason, and act in a complex environment to achieve a goal. It sounds kind of familiar. So one way to look at it, from what we just talked about, is that it's the synthesis of the strategic, long-term planning ability we pioneered with systems like AlphaGo, combined with powerful multimodal reasoning and world knowledge of a frontier model like Gemini. And it's that fusion of deep search and sophisticated reasoning that gives an agent its extraordinary abilities. I'll demonstrate a little bit what I mean. So let's quickly return to Go. As we discussed, you're faced with an extraordinary amount of complexity, more possible moves than there are atoms in the universe. So you can't calculate every single move in the game. Yet, AlphaGo learned to intelligently navigate the space and help us explore parts of the Go cosmos that we'd never seen before. It came up with amazing innovations like Move 37, and it's helped Go players ever since build on top of thousands of years of human knowledge. Well, it's kind of the same thing in AlphaFold. The same principles applied, and it was actually a bigger search space. So the search space for protein folding would be take every atom in the universe and stick a universe inside that atom, and you still wouldn't even scratch the surface of how complex it is to fold a protein. So here, instead of searching for also the best move on a board, our systems are learning to search for the best folded structure. The underlying challenge is identical. You have a mind-bogglingly complex space of possibilities, and an agent built to find the optimal solution within it. The concept also extends to many other things in life and business, finding optimal decisions without optimal information. And so here's the question for your businesses. If the same agentic capability can master the most complex game in the world and help us to unlock some of the secrets of biology, what is the impossibly complex space that you have to navigate? What if an agent, for example, could learn to search for the optimal logistics network to move goods globally, rerouting dynamically based on weather, port strikes, and tariffs? What if an agent could design the most stable power grid, balancing renewable fluctuation against real-time demand? The cycle and the pattern repeats. You might find that industries have their own grand challenges, their own high-stakes search for an optimal solution within a vast universe of possibilities. And maybe it's not as big as every atom in the universe having its own universe, but very few things in the world are. So how can we use agents as a force multiplier for human expertise in any capability, turning impossible choices into optimal decisions? I thought it might be nice to go through an example that's maybe a bit closer to home for folks. I want to look at the circulatory system of our businesses through the lens of procurement. This is DPW, after all. We'll start with this from a team manager. It looks seemingly simple, but I think as people in the audience will know, it hides a whole complex array of options underneath that. How many laptops, what specifications, what budget, what vendors operate in the country that my team is located. We find ourselves with another vast space of possibilities to navigate. So how might we solve it with standard tooling today? Maybe we turn it into a manual workflow of prompts. Maybe we query it with questions like, help me draft an RFQ, or list all of the vendors in Lisbon where my team is located. It might be helpful in some cases, but it still puts the cognitive heavy lifting on us. And so while it's not necessarily a bad place to start, it's a low-impact lever, and it's not clear that it's actually going to move the needle. Now, let's contrast that with an agentic system in an illustrative way here. Here, you don't give the system a prompt. You give it a goal. And the agent will then need to plan, reason, and act to explore that universe within the goal that you've just provided. So maybe it starts by determining the requirements of the goal that you've just requested. Maybe then it moves on to budgets and governance, and maybe it even needs input from you or from colleagues in legal and finance. Maybe then it looks at sourcing vendors and engagements before it can move on to executing purchases and maybe achieving that goal. The key takeaway for AI agents that I want to leave you all with is there isn't a deterministic path to achieving that goal. It's not follow these 10 steps every single time and you'll achieve that task. There's a certain degree of agency required for an agent because the space is complex, maybe new things come up. And importantly, here you have to work alongside the agent in order to unlock that value and navigate that complexity. And it allows you to deliver outsized impact as a result of that. And remember this, a diagram like this isn't science fiction. It's built on the same end-to-end stack that we just looked at. It uses the same frontier of models that we just presented, and it's built on that same rich tapestry of innovations over decades of very patient investment into fundamental science. And the point I want to make is it links us from AlphaGo to AlphaFold to your business. So we've established that there's incredible promise, but I did promise you as well that I would temper it. And so this is maybe one of the most important slides I'll flash up today. Looks simple. What I want to say is that the value is not inevitable. I can't stand up here and say, doing this is easy. You won't just go and turn on AI and expect your business to be completely transformed overnight. That's not possible. I've seen companies dismantle efforts or claim no impact from very significant investments because of this. It requires deliberate, thoughtful, and long-term work in order to succeed. And there are so many things, I think, that can increase the likelihood of success. Here, I've just picked 5. If you want the very, very, very long list, come find me afterwards. First, invest in your data. More specifically, the science of your data. You are the true experts of your industry, and that means you can unlock how that data is best used to guide these systems, in the same way that biologists have partnered with AlphaFold. Second, build your foundations. You won't run frontier models on legacy infrastructure. You need a scalable, robust technical platform. You don't want to build your skyscraper on a foundation of sand. Third, ride the frontier. What I mean by this is don't bet against the progress of model capabilities. If you spend 6 months, even 3 months or a month having to build a custom solution around a specific model, the capability waterline of new models, the models getting better over time, will rapidly rise and potentially drown out any investment that you and your company make. And so you have to build with the frontier and not against it. And often, one litmus test that I give to business leaders is if a new model comes out in 3 months or in a year, ask yourselves, will that make the thing that I've built better? Or does it potentially threaten and make the thing I've built obsolete? Fourth is evolve your organization. And this is maybe one of the harder ones. During the Industrial Revolution, it took decades to reskill the workforce. With AI, I don't think we will have decades. So how do you redesign workflows and create a culture of continuous learning now, today? For example, if you're incentivizing your teams based on hours worked, there's basically no incentive for your teams to actually use these tools to help improve their productivity. So don't use new tools for old jobs. And then fifth, design for impact. In complex systems, it's very attractive. We often look for the quick wins or the low-hanging fruit. It looks great on a promotion packet. It looks great to your bosses. It looks great to company leadership. But it doesn't work. For example, if we were to look at trying to solve a motor congestion issue on the highway, it's very tempting to say, if I add an extra lane on this motorway, it'll reduce the traffic jam. It's very tempting because it looks great on paper, and it's the very obvious low-hanging thing to do, but it never works. So you have to look for the high leverage points, the ones that require real foresight and patience. If you take these together, you won't just be using AI to write emails faster. I want you to use it to rethink impact for you and your organization. OK. This need for long-term vision brings me to my final slide, and I think brings us full circle. I promised that I'd cover a few things. We're on the precipice of something incredible. And I went through some of the amazing opportunities ahead of us, but I also made the point that the value is not inevitable, and it's going to take hard work from you. And I want to leave you with this image, or actually this video, thanks to Vio. When electricity first replaced steam, the companies that just swapped one big steam engine for one big electric motor saw almost no productivity improvements, no improvements to anything in their factories. I think it was less than 1%. The visionaries of the time, though, understood that electricity was different. It was about distributable power. And those same visionaries redesigned the entire factory floor and put small motors everywhere. And that single insight changed the face of manufacturing forever. And that's what unlocked the 1,000% plus productivity gains. I think we're standing at the same exact inflection point today. We shouldn't see AI as a better calculator or deploy it to do our current work faster. It's a scalable source of force-multiplying ingenuity for your problem-solving capabilities. And by the way, how incredible is it that we get to design and build this technology in our lifetime? One of the most important technologies, maybe, in human history. And we all have an incredibly important role to play in its development and its deployment. And that's because the future here isn't inevitable. It's not out of our control. It's your ingenuity, your expertise, and your vision that are the critical resources needed to solve it. And I think for the first time in history, we have the tools to truly scale them as well. And so my final call to action for all of you is simple. It's actually a question. What kind of leader will you be? Will you use the technology to simply optimize the factory that you already have? Or will you have the foresight and the courage to design a new one entirely? Thank you.